All right, sixth grade, we're ready to chapter 14 in science class today. To get started in chapter 14, I'll just scroll over here. We're talking about the building blocks of matter. I should maybe size out just a little bit. There we go. Okay, now one of the famous people we're going to talk about over here is Antoine Lavoisier. It says in 1782, America was nearing the end of the American Revolution when we won our independence from Britain. At the same time, another important event was taking place in a laboratory in Paris, France. The chemist, French, Antoine Lavoisier, was making one of the most important discoveries in science. His experiment showed that the mass of materials before a chemical change was the same as the mass of materials after the chemical change. These experiments led Lavoisier to conclude that matter cannot be created or destroyed. It can only change from one form to another. Lavoisier made many other discoveries. For example, he showed that air is a mixture of gases. He proved that one of these gases, oxygen, is needed to make fire. He also showed that oxygen is needed for breathing and to make metals rust. Lavoisier could have done much more, but his life ended tragically. After the French Revolution, Lavoisier was arrested and executed because he was part of the company that collected taxes for the government. How sad. Very famous scientist, guys. Gave us a lot of discoveries. We'll talk about the belief that matter cannot be created or destroyed. All it does is change forms as we work our way through this chapter. Okay, we're talking about the building blocks of matter. Obviously, last chapter we talked about matter, anything that takes up mass and has volume. So now we're going to dig a little bit deeper into those things. We're going to talk about all these wonderful things today. This chapter, from elements to atoms to solutions to compounds, as we work our way through that. Okay, we have an experiment. This sounds like a lot of fun. Some of you are like, man, what am I going to do today? What am I going to do this weekend? Well, what you can do is you can stick a mystery object inside some Play-Doh and then poke a toothpick into it and have them guess what's inside. So maybe you want to find a little sibling or a friend, stick a little dice in there, wrap it in Play-Doh and say, can you guess what's in there? That sounds like a lot of fun to me. I highly recommend it. Let's get to the skill. The skill that we've had now, I can't tell you how many times because it's number 3 on your sheet over here. If you can figure out how many times we've studied comparing and contrasting this year, you'll get it. Guys, it's a number, and if you want the easiest way is to go to the front of your book at the table of contents and just look up. Each chapter starts with a how to read science, and it'll say comparing and contrasting. You write down the number of times. And we got to study this a few more times before we get done with the book. Okay. Sometimes it's useful to compare and contrast characteristics of items to fully understand them. Use the following tips to find comparisons and contrasts when reading science articles. When comparing two items, we tell how they are alike. When contrasting, we obviously tell how they are different. So you might have got number 1 and number 2 in your notes there. You can use the information you read to infer how things are alike or different. In other words, sometimes you have to read between the lines. Like all matter, boron and nitrogen are made of atoms. That would be comparison in the middle. These atoms are so small they can only be seen with a very powerful microscope. In the middle. Their atoms have protons, neutrons, and electrons. In the middle. But their numbers differ. Boron contains 5 protons. That would be if I was putting boron on the left. Nitrogen has 7. That would be on the right. That's why the different substances with different properties. So they'd have different properties. Okay, your job is to do it. We're supposed to compare potassium and iron. Now, how am I going to get the information for comparing potassium and iron? Guys, that's on this side. So you're going to read a paragraph about potassium and iron. You're actually going to read 2 paragraphs, and they're going to give you some things that get sorted. So, for example, I read potassium and iron are both metallic elements. So I flip it over and I write the word metallic elements. Not the whole sentence, guys, just little things that go along with it. Okay, and then you can just go through the whole thing. Now, there's a few things that you have to do before that, guys. It says, hey, read the potassium and iron on the other side to fill in the Venn diagram. So you got that, but now you have number 4. One of the cool things about this, guys, is it talks about potassium and some of the cool characteristics of potassium. So I'm going to show you a video about potassium. As we go through that video, guys, you're going to watch for what they used to cut the potassium. What color was the light of the little device? He's going to stick a device in potassium. It's going to light up to show that it conducts electricity. Look for the color of the light. Then he's going to put it in water, and we're going to see what happens. And finally, at the end, he's going to mix a solution, and your job is to see what happens to all those things. All right. Here comes your video to answer the questions for 4.
If we continue down the column to potassium, we see that the potassium metal is also stored under mineral oil to minimize its reaction with the oxygen in the air. If we remove a piece of potassium metal, we can see that the potassium is coated over with a gray coating of the oxide. As we continue down the column, group 1 metals get softer and softer. The potassium cuts very easily. As we cut through the metal, we expose the shiny metal surface underneath. The potassium is extremely soft. We can easily flatten out the potassium metal. It has a consistency of cream cheese. The potassium is a metal and is an excellent conductor of electricity. If we add a piece of potassium metal to water, we see that it reacts much more rapidly with the water than the sodium. As you go down the column, the ionization energy decreases and the metal reactivity increases. The reaction is very exothermic, and the hydrogen that's produced ignites. We can test for the formation of potassium hydroxide by adding phenolphthalein. The solution turns red-purple due to the formation of potassium hydroxide.
So guys, you can see some cool things that come along with potassium there as we are looking at that. You saw what he cut it with. There's 2 different colors that it lit up. One or both, doesn't matter to me. You saw what happened when we dropped those little pieces of metal in the water there. And then you got the description of this color here that shows all those things. Now that's just answers A, B, C, D here, guys. And then make sure you do this Venn diagram at the top by reading these 2 paragraphs on that side. So you're just going to have to flip it back and forth a few times to get those things answered. Okay. Kind of a fun little experiment that you can watch. Have a great day.